So yes, that's a very good answer. Square root of 3 is a number on our chart that we've memorized, but it doesn't go with cosine, it only goes with tangent. So what am I going to have to do? So I'm going to use inverse cosine. So I'm going to need theta is inverse cosine of square root of 3, and I will need theta equals inverse cosine of negative square root of 3. I'll have to do them both. This one's positive, I should get answers in 1 and 4. This one's negative, I should get answers in 2 and 3. I push some buttons on my calculator and it says a bad thing. What's the calculator say? It says error. It certainly does. Does it matter which one you do? No, it says error for both of them. What's wrong? It's outside of the boundaries. What are the boundaries for cosine? Negative 1 and 1, and square root of 3 is bigger than 1.
How would we do it still? Fraction.
No, a fraction wouldn't work because square root of 3 is bigger than 1, and it can't be written as a fraction. It's an irrational number. But 1 over the square root of 3 is not the same as square root of 3. 1 over the square root of 3 is the same as square root of 3 over 3. They're not true. No. The moral of the story is, what's the answer to this equation? There are no answers. That's correct. So the answer is no solution.
Why do you make it all the way to
Well, because sometimes that happens. Sometimes that's the right answer. Yeah, it's not very satisfying. I agree. It's not very satisfying to do all that work for the answer to be there is no answer. But that happens. All right, part B. Part B also has an issue. I do have a sign here and I do have a sign there, so the signs match. That's pretty good. But what's the issue with this one? One of them has a sine 2 theta, and one of them just has a sine theta. The angles are different. So in general, we want really two things to happen. We really want the functions to be the same. So in this problem, we made them both cosines. We also want the angles to be the same. So I need to do something with this sine 2 theta. What am I going to do with that? I can't factor out theta. I can use you said the right one first. The angle is being doubled, so this is the double angle formula. So that's 3 times sine 2 theta. You look it up on the chart that you're going to get on your test. Sine 2 theta is 2 sine theta cosine theta minus 2 sine theta equals 0. All right, so that worries me a little bit. I mean, it's an improvement. I got rid of the sine 2 theta, but it does worry me a little bit that now I have a cosine and I have a sine. But I think we're okay. What can you do with that equation now? Divide by what? I can factor out a sine. So I have a sine here and a sine there. Sine is common. So I'm going to factor a sine out. Sine theta times, left over would be 6 cosine theta minus 2 equals 0. That's going to give me sine theta equals 0. This one's going to give me cosine theta is 1/3, because I would add the 2 and divide by the 6. Theta is, when is sine of theta equal to 0? 0 is one answer. Any other answers? Pi. Okay, theta equals pi plus 2 pi k. Good. Any other answers? Technically, there are an infinite number of answers. Have we listed them all? Yeah, because it would be 0, then pi, then 2 pi. But 2 pi is covered by this one. So we've got them all there. Cosine theta equals 1/3. Is that one of the famous ones we've memorized on our chart? No, so we got to use that cosine inverse button. So theta is, what's the cosine inverse of 1/3? 1.23. Since web assign requires 2 decimal places, we'll use 2 decimal places. That sounds good. Any other answers?
Well, that would be quadrant.
That would be in quadrant 1. There's another answer in quadrant 4. So the negative of it. Theta equals negative 1.23 plus 2 pi k. I think that's it. I think that's all 4 answers. Questions on that one? All right. Moving on to number 2. Kind of a similar issue. This one has a sine 2 theta in it. But kind of not the same issue too, because the previous one had a sine 2 theta and then a sine theta. And that was the issue with that one. So for this one, we had to use a double angle formula to get everything to just be thetas. What about this one? Any ideas? Don't have to what? For this one, I don't think we have to, no. I think this one I would start by dividing both sides by 2. Sine of 2 theta equals a half. You're close.
Or a half divided by half.
What if this 2 were not here? What if it just said sine theta? You would do inverse of sine, wouldn't you? So how do I get rid of a sine? I still do inverse sine. Does it matter that I have a 2 theta there?
No, we'll just divide everything by 2.
I'll divide everything by 2 later. That's correct. So we're going to have 2 theta is sine inverse of a half. Is that one of the famous ones we know?
Yes, it's
It is pi over 6 plus 2 pi k. That would be the answer in quadrant 1. The other answer would be 2 theta. Oh, we'll divide by the 2 in a minute. Don't worry. So this is the answer in quadrant 1, pi over 6. We also need an answer in quadrant number
No, all suckers. So 2, 5, 6.
2, which is 5 pi over 6 plus 2 pi k.
Why did you want to divide?
All right, then we take both of these little equations that we have and we divide both sides by 2. So our answer is theta equals pi over 12 plus pi k. And over here we have theta is 5 pi over 12 plus pi k. Make sure when you divide by 2, you divide everything by 2, including the 2 pi k. No. We'll talk about why pi k here in just a minute. We're not quite done yet, because the direction said, first find all solutions. We found all solutions, here they are. Then find all solutions in 0 to 2 pi. So, how do I find all the answers that are only between 0 and 2 pi? Yeah, it's one complete revolution, that's true. Well, I'm going to pick my favorite numbers for k. I'm going to pick k equals, what's my favorite number to pick? 0. 0 is always my favorite number to pick, because 0 is always the easiest number to plug in. If I plug in 0, this one gives me theta equals pi over 12. And this one would give me theta equals 5 pi over 12. Those are both between 0 and 2 pi. Now, I heard somebody say plug in k equals -1. I don't want to use -1. Not for this problem. Because if I plug in -1, I'm going to get pi over 12 minus pi. Is that going to give me an answer between 0 and 2 pi? No, it's going to give me a negative answer. So I don't want to use -1. So I use 0. So what's my next favorite number? Plug in 1. K equals 1. That will give me theta equals pi over 12 plus pi. Pi is 12 pi over pi, so pi over 12 plus 12 pi over pi, or 12 pi over 12, I mean, is 13 pi over 12. And I plug in 1 over here, 512 over pi plus pi, that's 5 pi over 12 plus 12 pi over 12, that sounds like 17 pi over 12. What's that? Can I? Yeah. Raise it. And then I think I'm all done. Why do I think I'm all done? What would happen if I plugged in k equals 2? I would have pi over 12 plus 2 pi. That's bigger than 2 pi. Same with this one. That would be bigger than 2 pi. So I think that's it. I think there are 4 answers between 0 and 2 pi. Why did we get 4 answers? Usually when I solve a sine equation between 0 and 2 pi, I only get 2 answers. How come this time we got 4?
Oh, because we can do it either one way or the other.
No. I mean, for example, look back up here. I had sine equals 0. I got 2 answers from the sine. And I had cosine equals a third. I got 2 answers from the cosine. Usually we get 2 answers. How come this time we got 4? And why did I only add pi? Because this angle was 2 and I had to divide by 2. Think of the graph. What's this 2 do to the graph of sine? Cuts it in half which way? One of those is correct. There's only 2 choices. Normally, if I graph sine theta, it looks like this. One cycle starts here at 0, 0. Where does one cycle end? At 2 pi. So this would be sine of theta. What does that 2 do to the graph?
Oh, that's a formula.
That's right. It changes the period. So between 0 and 2 pi, this graph is going to make 2 complete cycles. So it's going to have, where y equals 1/2, it's going to have 1, 2, 3, 4 answers. What if instead of a 2 right here, what if I gave you a 3? How many answers should you get? 6. If I made this a 12, how many answers should you get? 24. So you're always going to have, whatever this number is, you're always going to have 2 times that number of answers because it changes your period. Would I give you a 12 there? No, I don't think I would. But I think a 2 or a 3 or a 4 would be reasonable there. Have you something? Yeah, no. Maybe I'll be mean and give you a 4. Similar problem. Tangent of pi over 4 equal plus square root of 4 equals 0. What would you do? Holy moly, you'd say. And then what would you do? Subtract square root of 3. So tangent pi over 4 equals minus square root of 3. So theta over 4 is tangent inverse of minus square root of 3. Tangent inverse of square root of 3 is that one that we've memorized.
Is it square root of pi over 3?
Is pi over 3? And so what?
Negative pi over 3.
And because of this negative sign, it would be negative pi over 3. Correct. So it would be negative pi over 3 plus pi k because the tangent has a period of pi. Very similar to what we had to do last time. Now we multiply both sides by 4 to get rid of the fraction. So theta is negative 4 pi over 3 plus 4 pi k. So there's all the answers. And then once again, we want all of the answers between 0 and 2 pi. So what am I going to do? If it were 4 times theta, I would be expecting 4 answers. It's divided by 4. How many am I expecting? Less. 1 or possibly 0. Because normally we would only come up with 1 answer, but dividing by 4, I'm going to come up with fewer, potentially. So how do I find them? Well, I start picking my favorite numbers in the whole wide world for k and plugging them in. What's my favorite number in the whole wide world? 0. But if I plug in 0, I'm going to get negative 4 pi over 3. Does that give me an answer between 0 and 2 pi? No, because it's negative. So 0 is not going to work. So what's my next favorite number? 1. So if I plug in k equals 1, I'm going to have theta is negative 4 pi over 3 plus 4 pi. That's negative 4 pi over 3 plus 12 pi over 3, which is 8 pi over 3. Is that between 0 and 2 pi?
No.
Yes, no, maybe.
Larger.
It's larger because 2 pi would be 6 pi over 3. So this is actually larger than 2 pi. So there are no solutions between 0 and 2 pi. There are still an infinite number of solutions to the original problem, but this one has no solution in the interval 0 to 2 pi. And that can happen. It can happen that the equation has answers, just not between 0 and 2 pi.
So would it, on the website, would it say, made us write no solutions in
No. Normally it just has you put like one letter, like a N for no solution.
Okay. On your test, are you going to make us put it in 0 to 2?
Probably not, no. If you give me this and then roll off to the side, no solutions, that'd probably be fine. All right. Taking my word for it. Good.
I know you said probably.
Probably.
You never know.
You never know.
Have you been written the test yet?
Yeah, I have actually. I'm way ahead. I did actually write the test. No, I haven't done the review. I'll do that
You're not way
soon.
ahead. You said you were going to give it to us this past weekend.
Yeah, but then we delayed the test for like a whole week, so I had more time. I'll get it up soon.
I'd like to do this weekend.
Okay, I'll have it by this weekend.
Like Friday this weekend? Or like before this weekend or like Sunday night?
Probably I'll do it tomorrow
Okay.
because I have my online students are taking a test tonight, so I'll be proctoring them and then grading their exams, and so probably tomorrow night is when I'll do it, unless I forget.
So you have to, your online students have to come in with a big test?
Yes, they do. No. All right, we'll skip C for a minute. We'll come back to that, or we'll assign it for homework, one or the other, maybe. We'll see. How about number 4? Hint, factor by grouping. I did say that. What do I mean by that?
That you will factor out 4 sine theta plus 2 sine theta, and then factor separately 2 cosine theta less 1.
All right, so factor by grouping is a technique that quite often works when you have 4 pieces, 1, 2, 3, 4. And so when I say factor by grouping, what I mean is put the first 2 together and then put the second 2 together. That's exactly what you just said. Yes, it is. I wasn't sure everybody heard you, though. All right, so what can I factor out of the first group? What's common here? 2 sine theta. I'm going to take out 2 sine theta. And then what's left? 2 cosine theta plus 1.
Why would you still have 2 sines? If you have 4 sines.
No, because 2 sine times 2 sine would be 4 sine squared. Right? This sine and this sine I took out front. That's this sine and this sine. It's a random function in this case, actually. What's common in the second group? A negative 1 is really the only thing common in the second group. So we'll take out a negative 1. What's left over? 2 cosine theta plus 1. Why does it have to be a plus 1? Because negative 1 times plus 1 gives me the negative 1 back. And besides, if you remember your factor by grouping, when you do factor by grouping, those two things need to match up perfectly. The next step is these two things match perfectly. So you factor them out. So you write down 2 cosine theta plus 1. And if I take those away, what's left over? 2 sine theta minus 1. Alright, so now that we factored, we set each one equal to 0. This one's going to give me cosine theta equals negative a half. And this one's going to give me sine theta equals positive a half. Alright, let's do the sine one first because that one's easier. Theta is. That's one we've memorized on our table. Sine of what will give you a positive 1/2? 5/6 plus 2 pi k. And then how about the answer in quadrant 2? 5 pi/6 plus 2 pi k. Alright, now this one's a little bit harder. If this were a positive 1/2, then the angle would be pi/3. But since it's a negative 1/2, what do I need to do? That's correct. All right. Since this is a negative sign, cosine is negative in quadrants 2 and 3. So I need to take my pi/3 and move it to quadrants 2 and 3. So in quadrant 2, it would be pi minus pi/3, which is 2 pi/3. And then in quadrant 3, it would be pi plus pi/3, which is 4 pi/3. So you do have to convert those to quadrants 2 and 3. So that one's a little bit of a pain. Not too bad though. It looked a little scary. But we're getting really good at these pi/3 things now at this point in our life, I hope. All right, so it looks like to get the answers between 0 and 2 pi, I'm going to use k equals 0. If I plug in k equals 0, I get pi/6, 5 pi/6, 2 pi/3, and 4 pi/3. And I think that's it. Because what's wrong with using k equals 1? I would be adding 2 pi to all of those, so they're all going to be bigger than 2 pi. So I think that's it. This time we only have to use k equals 0. Questions on that one? All right. Good question. Next one. It says, you've got cosine theta, cosine 3 theta, minus sine 3 theta equals 0.
One of the things we don't have to memorize.
It's one of the things you don't have to memorize. That's correct.
I think it's not tangent. I'm thinking it's cosine. Then sine is cosine. Sine. Sine. I'm pretty sure sine is cosine. I think it's cosine positive.
I think it's cosine positive too. Because you look on the chart that we have a formula that says cosine of u plus v. When you have the cosine here, it goes cosine, cosine. And then the sign switches. When you have a plus here, you get a minus there. So it's sine, sine. So, cosine theta, cosine 3 theta, minus sine 3 theta is a fancy way of writing what? Cosine of theta plus 3 theta. This is the same as cosine of theta plus 3 theta. using this formula from right to left. In past sections, we always used it left to right. Today, we're using it right to left. Well, cosine theta plus 3 theta, that's cosine 4 theta. Cosine 4 theta is 0. I do cosine inverse on both sides. 4 theta is cosine inverse of 0. So 4 theta is, what's the cosine inverse of 0? Pi over 2 and 3 pi over 2. Cosine of 0 is, cosine is 0 at pi over 2 and 3 pi over 2. All right, well, much like we've done on a couple of the past problems, we divide both sides by 4. So theta is pi over 8 plus 1/2 pi k. And theta is 3 pi over 8 plus 1/2 pi k. How many answers are we expecting to get this time between 0 and 2 pi? We are expecting to get 8 of them. Why are we expecting to get 8? Because this is a 4. We should get twice as many answers as whatever that number is.
Which usually makes sense.
All right, so I don't know where to write here. I guess I'll put them down here. So I start by plugging in k equals 0. When I plug in k equals 0, I get pi over 8 and 3 pi over 8. I like that one. That one's easy. I plug in k equals 1. I'm going to have pi over 8 plus 1/2. Five pi over 8. And then the next one is 3 pi over 8 plus pi halves. 7 pi over 8. Okay. I keep going. K equals 2. So now I'm going to have pi over 8 plus pi. 9 pi over 8. Without thinking much, can you tell me the next answer? Let's see. 1, 3, 5, 7, 9. Seems like the next answer better be 11 pi over 8. And when k equals 3, 13 pi over 8, 15 pi over 8. So when you have one that has a lot of answers like this, you should see a very obvious pattern after doing a few of them. So once you do a few of them, it's going to go quickly and easily. It shouldn't take you long. Why is that the end? Correct. First off, I have 8 answers, which is what I expected. If I were to now plug in 4, I would have pi over 8 plus 2 pi, and that's bigger than 2 pi. So that's how you know when to stop. You know when to stop when you plug in a number that gives you something bigger than 2 pi. But you should be anticipating that I should get 8 answers, so once you have 8, you should be anticipating I'm all done. Questions on that one? About how many problems per section? I don't know, but I would say it's pretty evenly distributed. It's not like 7.3 was the hardest section, so I picked the most problems out of that one. I did, but I did not do that. I promise you.
How many questions do you have?
I want to say 2.
How many points?
75. I'm just kidding. I don't know. Yeah, but I wrote 4 tests this week. I don't remember years that specifically. I got 4 other classes that have tests. So, anyway, it's pretty evenly distributed among all the sections. So that's kind of good news because remember chapter 6 was quite a bit easier. So, about half the stuff comes from chapter 6 and about half from chapter 7. So, We'll see. All right, F. F is similar to a problem we had before. We've got an issue that we have a 2 theta here, but we only have a theta there. But this one has a squared, which looks worse, but turns out to be better. We'll see why in a minute. What are we going to do? We can't factor out cosine because this one has a 2 theta and that one has a theta. They're not the same. They have different angles. What did we do before when we had one that had a double angle and a single angle? We used a double angle formula to get rid of the double angle. So what's the double angle formula for cosine? No, you do not have to have it memorized. That's one of them. I think that's the useful one. This one actually had 3 different formulas. 2 of them involved a sine squared. Do I really want a sine squared in this problem?
Yes.
No. I really want a cosine squared because I already have a cosine squared. That's true. But I think I'd rather just use the formula that doesn't give me any sine squares to begin with. So, when you use the cosine double angle formula, you have 3 to pick from. But I think the clever one for this problem is to pick this one, 2 cosine squared theta minus 1. Because then my problem only has cosine squareds in it. If I use one of the other ones, my problem's going to have cosine squareds and sine squareds, and then I'm going to have to deal with, well, I can only have one of them. So I'll pick the one that only has one from the beginning. Makes your life easier.
So basically, put whatever's inside,
For this,
double angle.
yeah, for cosine, it happens to work that way, if that's how you want to remember it.
So, what would you give us something like cosine 3 theta minus cosine squared theta? Because then
I would not expect a problem like that because we do not have a formula for cosine 3 theta. So no, I wouldn't expect something like that. All right, well, I combine these 2. That gives me cosine squared theta equals, and I move that 1 to the other side, so cosine squared theta is 1. Which means, of course, cosine theta is plus or minus 1. Cosine of pi over 2 is 0. Not 1. 0 is one correct answer. Cosine of 0 is 0. That's one correct answer. Plus 2 pi k. And cosine of pi happens to give you a negative 1. And those are the only spots. That's it. The only time you get 0 is when you have 0 or 2 pi or 4 pi or all the coterminal angles. And the only time you get negative 1 is when you have pi or 3 pi or 5 pi or all the coterminal angles. So all the answers between 0 and 2 pi, there's only 2 of them. 0 and pi. All right, G. The problem with G, once again, is that we have a sine and we have a cosine. That's a bad thing. If I had sine squareds or cosine squareds, I'd know what I would do. I would use the Pythagorean identity, but I don't have sine squareds or cosine squareds. And so there's a hint. The hint is square both sides. Why do I want to square both sides? It'll do what? It'll give me, what's going to happen when I square this? I'll get a sine squared, and when I square that one, I'll get a cosine squared. But it's not quite that easy. When I square both sides, I have to take sine theta minus cosine theta squared equals 1/2. I got to FOIL it out. But it's going to be okay, I think. Because when I FOIL it out, I'm going to get sine squared theta minus 2 sine theta cosine theta plus cosine squared theta equals 1/2. And I think some good things happen. What are the good things that happen?
And I don't know if you're allowed to, but I guess it's a puzzle position and the sine squared next to the cosine squared. That connection.
So you're asking, can I change the order when I'm adding stuff? Can I change the order when I'm adding stuff? Yes. What's the name for that? Commutative property, not commutative. There's no commune in commute. Commutative. Commute is to move. So you're absolutely right. Sine squared plus cosine squared is 1. I can put those together. So this is minus 2 sine theta cosine theta plus 1 equals 1/2. I'm going to subtract that 1 to the other side. So minus 2 sine theta cosine theta equals minus 1/2. But I still have a problem. I still have a sine and a cosine. I want to divide by -1, actually. And I have a really good reason for that. I'm going to divide both sides by -1. Now I see something that I recognize. 2 sine theta cosine theta, that's one of our famous formulas. That's the double angle formula for sine. That happens to be sine 2 theta equals 1/2. Alright, so this one's a tricky one. Tricky because first you got to square both sides and use the Pythagorean identity, and then you have to recognize this double angle formula right here. No, I'm happy now. I'm happy because I only have sine, and I can get rid of sine by doing what? Inverse sine. And then later on, I'll divide by the 2.
Don't you have to square both sides, not just the sine minus cosine?
All right. You're absolutely correct. When I said square both sides, I really should have squared both sides. I neglected to square the left-hand side. All right. I guess I'll do it the right way if you want me to. I'm just going to change all of these. So 1/2 squared is 1/4. That one's still a 1/4. I subtract the 1. What's 1/4 minus 1? Minus 3/4. So then I divide it by -1. I have 3/4. So I have 3/4. I liked the 1/2 better because that was a number I knew. But you're right. I guess I should do the correct answer. All right. See, everybody makes little mistakes every now and then. That happens. All right. So the point is, now we can do inverse sine on both sides, and we will have 2 theta is. We grab our calculator. What's the sine inverse of 3/4? Not one of the famous ones we know. Calculator says. 0.85 plus 2 pi k. And then I need the answer in quadrant number 2. How would I get the answer in quadrant number 2? How would I get the answer in quadrant number 2? 0.85 is in quadrant number 1. Pi minus 0.85. So what's pi minus 0.85? How much? 2.29? 2.29 plus 2 pi k. All right, then we're going to divide both of those by 2. So theta is 0.425 plus pi k. Theta is 1.45 plus pi k. I hope you're checking my division. Yep. Dividing by 2 is not so hard. Okay, so it looks like how many answers are we going to have? Looks like we should have 4 answers. So our 4 answers should be theta is 0.425. Theta is 0.425 plus pi. Over here, theta is 1.145, and then theta is 1.145 plus pi. Last thing I need to do on this problem is I need to check. How come I didn't check on any of the other problems? But I'm telling you, you better check on this one. So between 0 and 2 pi, yeah, that's not the problem. The problem is way back at the beginning, what was the very first thing we did? We squared both sides. And what happens when you square both sides? It cancels out negatives, which sometimes gives you what's known as, oh God, the word just slipped right out of my mind. Erroneous, that's the word, erroneous solutions. For example, if I were to give you square root of x equals -2, and you were to square both sides, you would have x equals 4. Is x equals 4 an answer to that equation? No, because squaring both sides eliminates negative signs. We squared both sides way back at the beginning, which means this negative might have been an issue. So you would actually need to physically take 0.425 and plug it back in and see if it works. And then 1.145 and see if they work. Now, we did round off a little bit, so you're not going to get exactly 1/2, but it should come out really, really close to 1/2. So what happens when you plug in 0.425? You get a negative, so 0.425 doesn't work. Got to cross that one off. Plug in 1.145. It's really, really close to positive 1/2. Yeah. All right, so this one's good. Now, here's what's going to happen. Since 0.425 didn't work, I'm sorry. Well, because we squared both sides, we're not going to get 4 answers. Because this one didn't work, this one's not going to work either. Because this one did work, this one will work. So what happens is this is actually completely wrong. That is not a solution. 0.425 plus pi k is not going to work. So those are kind of a pain in the neck, but that's something you need to watch out for. If you square both sides, you're going to get multiple answers, and quite often some of those answers are not going to work. You've got to plug them in and check them to make sure. Questions on that? All right, so there's one problem we did not do. Homework problem. Take it home, see what you can do. Questions?
Wow.